Okay, so good morning, everybody. Thanks for joining today. Quick introduction of myself. I'm Fernand Mitstein. I'm the co-founder and CEO of Biggs Ventures. It's a venture studio, so we create startups, I would say, working with lots of universities in Europe these days and in North America. And these startups are focusing on climate technologies. And I'm also one of the business partners of Smart that I would like to thank you. Thanks for having me here today. I will start by introducing our panelists. So again, the idea, the focus is really to discuss today what have been the challenges of moving from a research and development into, I would say, viable business model. So that's exactly what we are going to talk about. The first panelist is Mr. Thijs Mestiri. He comes from Orléans in France. He works for he works for CBEX. CBEX's mission has been to really revolutionize agriculture using artificial intelligence and data analytics. So it's one of the first cases where you see AI working for the planet. As a chairman and recently CEO, he is deeply involved in creating sustainable farming practices that enhance crop yields and optimize water usage. His team's dedication aligns with CBEX goals to deliver innovative, sensorless precision irrigation systems that support a more sustainable future. He has been recognized as a top innovator by the World Economic Forum's Uplink. He leveraged his expertise in IT system and AI to advance agricultural technology. His team has successfully implemented AI-based decision support systems, empowering farmers with precise, actionable insights for resource management, demonstrating their commitments to leading agtech innovation. So welcome, Tahir.
Thank you.
The next speaker is Mr. Abbas Khan. Welcome, Abbas. Abbas is a Chief Strategy Officer at Tanyan Food Company here in Saudi. With more than 25 years of experience, he is a CPA. He worked for investment banks and Islamic finance. He joined Tanya about 6 years ago, and he's responsible for 4 key areas, being organic growth, inorganic growth, digital transformation, and sustainability. He has been responsible for ensuring that the expansion plans of the company and its operations are sustainable, including building waste management strategies and circular economy in the company. And you recently was part of a panel discussion in the Zero Food. And then the last speaker is Dr. Pascal Sekali from Coast. So he's a professor of environmental science and engineering at King Abdullah University of Science and Technology. He is a Chief Scientist Officer and co-founder of New Rain Wastewater Company. So we will talk more about New Rain. He joined Coast in 2010 and began his research quest to develop innovative and sustainable environmental biotechnologies for wastewater treatment and reuse. And he translates with that novel wastewater treatment biotech from bench scale to full scale. His research is acknowledged globally, and he's a regular keynote speaker at international conferences. He has authored or co-authored over 145 articles in peer-reviewed scientific journals, and is one of the editors of Water Research. And you were selected as the 2024 International Honorary Member from the American Academy of Environmental Engineering and Engineers and Scientists. So, long presentation, but I thought it was quite meaningful to give all your background. So I will start the first question with you, Tahir. So CBEX has successfully transitioned from research to commercialization in the agtech space. What were the biggest challenges you faced during this journey, and how did you overcome them?
Yeah, thank you very much, and thank you for all the people here that invited me. It's very interesting to be here, and it's a very interesting topic because actually I selected 3 challenges that we faced because, you know, for a startup there is so many challenges. But the top 3 for me was first to meet the user's expectations. You know, today I know that the session of today we are talking about R&D to commercialization, but I think it's very interesting to go the opposite way and start from the user's expectations and the possibilities of commercialization and go all the way to the R&D so that we don't just create innovative solutions, but also impactful solutions that have a market, that are here to answer users' needs. So to be able to meet these users' expectations, first we started like a lot of other companies in my first experiences in building startups. We started from the technology, but the problem is that you cannot make it efficiently to the commercialization. And with CBEX, we did it the opposite way. And we built groups with farmers, leader farmers, and we asked them, okay, actually, what is your problems? For example, in irrigation, water use, how can we help you in reinforcing your capacities? And we gathered a good, let's say, details about what is their needs, what we should do to help them, and we built a product, and then it was very much easier for us to go through this path from research and development to commercialization. So this is the first one. The second one, we are working in agriculture. You mentioned it. We are working on precision irrigation, sensorless precision irrigation, and in agriculture, we are talking about very long times. The timeline for agriculture is different from tech and consumer-oriented products. And to iterate or to build a new product and test it, etc., we are thinking about or working on seasonal cycles, and it takes a lot of time. And to overcome this challenge, we have been working on historical data and working with partners that have already experiences, and we built on these experiences to adjust, to iterate, to work on simulating actually we are working on the soil water content, and we simulated on this. And with this we have been able to have a good chance to iterate without waiting for a new season and another season, etc. And the last one is the funding. I mean, when we are talking about these big or long timelines, funding is quite a problem, especially in this field. And we have been able to achieve early tractions and convince investors with these tractions, and we have been able to secure some kind of funding to be able to achieve our objectives during time, while being also in some way comfortable with the funding side. But also we diversified the funding sources. We have been using equity, but also financing from private and public institutions, from grants, etc. And it's very crucial to be able to have this treasure of war, let's say.
Yeah. And the second questions we had was, CBEX, you operate in a diverse agricultural context. So how can you make sure that what you deliver in terms of solution is scalable and adaptable to different regions and farming practices?
Yeah. For scalability, what we call hyper-scalability, we got at least two barriers, major barriers. The first one is, that was the solution for a lot of our competitors that we consider potential partners, is when you are hardware-based, you have big problems with scalability. So that's why we built an AI-based platform that is sensorless to help farmers take the right decisions in irrigation. And by being sensorless, we are highly scalable. And that was the first barrier, to move away from hardware. And the second one was, how can make our insights understandable by the farmers? And for this, we just released last month an AI agent that is able to understand natural language questions and answer the farmer or the user in his own language, in more than 100 languages and dialects, using his own data that has been generated on our platform. I mean, we have reached this point where a farmer can ask a couple of questions like, do I need to irrigate today? If I need to irrigate, how much? And answer exactly in his own language, in his own dialects, the information that
so it's really human-centric technology.
Yeah. absolutely.
Okay.
And yeah, this one thing, but just to finish about this scalability, I mean, it's very, very important also to go through distribution channels, massive distribution channels. And to finish about this, actually, we are building agri value chains, and we are going through agri value chains, and through agri value chains, we are able to reinforce capacities of farmers at scale, but also aggregate a lot of data coming back and help them in developing their supply chain and stabilize it.
Thank you, sir. So Abbas, you are the Chief Strategy Officer in a food processing company, which is the second business one in KSA. And we know that food production consumes tons of water.
Yeah.
So the question is, what are your strategies for better water consumption and waste management in general? And the sub-question is, have you been working with startups to help you in implementing your strategies?
Yeah, thank you. So Anmia's strategies is broken down on two pillars. Pillar one is the present. Continue to do what we are doing, right? So the water that we consume is treated. We are building a project. We've launched a project to plant 1 million trees using treated water. We've already planted around 500,000 trees behind our facilities, just 2 hours drive from Riyadh.
Yep.
The other element of our strategy is to look in the future. And when we look in the future, we have to look at some data points for Kingdom. So Saudi is an arid zone. The natural resources of the natural water is around 2.4 trillion liters per annum. If I compare it with a country like Brazil, from where most of the corn and soya comes, which is a main ingredient for our feed, the number is 8,200 trillion liters. 2.4 versus 8,200, right? But we have to do the business. So we are using that water. So the future projects that we are looking at is how we can grow corn and soya locally. So moving the environment from the picture, using limited water sources that we have. And for that, we have 3 main projects. Project number 1 is waste to value, where we are converting poultry waste into biochar, and then from biochar into biodegradable plastic. This project...
Can you maybe explain what is biochar?
So biochar is a carbon-rich material. You mix it with the soil. It helps you retain water. It helps you increase the nutrients within the water, which helps you grow with little water consumption. At least 20 to 30 liters of water can be saved if you compare with the normal irrigation system. We launched a project, we launched a grand challenge called Omnipreneurship $1 million. A startup, referring back to your second part of your question,
yep.
A startup from King Abdullah University of Science and Technology won that. We gave them 1 million, and now they are working in commercialization of that technology, whereby biochar can be converted into biodegradable plastic, which will be used for irrigation. Okay. The second challenge that we have launched, and we are about to finalize, again, a $1 million prize that will go, is how to grow corn and soya locally. Okay. Just to give you some numbers, corn, for 1 kilogram of producing corn, it takes 900 liters of water. Soya, you double it, around 1,800 liters of water per kilogram.
Terrible.
It's incredible. And that makes 60 to 70% of the poultry feed that we consume, or the ruminants consume. So one area is to look at how we can grow it locally. The other leg, the other element is to look for the future, to look for alternative solutions. And that's where we are working again with some of these startups and some of the established companies from Europe, is to look at something called black soldier fly. It's a normal fly, which basically consumes 95% less water, okay? It gives you the feed, which is 40 to 50% full of protein, fats, fatty acids, amino acids. Middle East and Africa is in terms of its usage globally, is at the bottom end. Asia Pacific, 50% of the conversion of this feed is being used. Europe comes second, 22%. We are working with SFDA, Saudi Food and Drug Authority, and MIVA to co-develop policies around this for the usage of this. United States have approved the use of this in 2018. And to me, given the water scarcity in Saudi Arabia, that's a game changer.
Absolutely.
So, imagine 900 liters of corn, 1,800 liters of soya versus 15 to 40 liters per kilogram of feed. So our strategy is continue to do what we do, and at the same time having one leg in the future.
Fascinating. Thank you, Abbas. So, Professor Sekali, so you, again, you are professor at Coast University, and you are also at the basis of a well-known startup in the country. So, the question for you is, what do you see as the current global challenges in the centralized wastewater treatment and the opportunities for innovation in this wastewater sector, and transforming these innovations from lab into market-ready technologies to address the current pressing issues such as water scarcity?
Well, thank you, Fernand, for the introduction and the question. So currently, only 30% of the wastewater that is generated globally is treated safely before discharge. And it's being treated using a centralized sewage infrastructure based on a technology called activated sludge technology that was invented more than 110 years ago. Now, this technology is very energy intensive, consumes 4% of the global electricity, and it generates 500 million metric tons of sludge that need to be handled. In addition to that, it generates a lot of greenhouse gases, mainly methane gas from pumping the wastewater, and methane is 80 times more potent than carbon dioxide. It also generates nitrous oxide from the treatment of nitrogen in wastewater, and nitrous oxide is 300 times more potent than carbon dioxide. In addition to that, the conventional activated sludge technology does not generate a treated sewage effluent suitable for non-potable use applications. Now, another challenge for centralization is that in many places around the world, there's no full coverage of sewage network to the centralized sewage treatment plants. For example, in Saudi Arabia, there's only 60% of the households that are connected to the centralized sewage network. This means that the wastewater from households that are not connected to the centralized treatment plants, they're collected by trucks and transported to these treatment plants. So trucking is costly. It costs, for example, around 200 to 150 SARs each trip. In addition to that, it generates air pollution and greenhouse gases. Now, expanding the underground infrastructure for sewage is very expensive. Also, pumping the wastewater for a long distance costs a lot, like around 0.3 kilowatt hours per meter cube. So with these grand challenges, we saw an opportunity for innovation. So at KAUST, we basically invented a decentralized wastewater treatment and reuse technology. We call it New-Rain technology, which basically is based on a granular sludge technology integrated with gravity-driven membrane. So we started our journey of R&D in 2018 with a small-scale system, 12 liter per day capacity. Then we expanded the capacity to 150 liters per day. And we compared its performance to a full-scale aerobic membrane bioreactor. So aerobic membrane bioreactor is the gold standard for wastewater treatment and reuse. So it's important in R&D, you always need to benchmark with the state of the art. And based on the performance that we received in our technology, we actually exceeded the aerobic membrane bioreactor by 80% on nitrogen removal and phosphorus removal. We managed to reduce the energy consumption by 60%. Then we scale up the technology to 100 meter cube per day capacity, and we validated the technology at the Rabeck sewage treatment plant, and we're still running the treatment plant until now. In addition to that, we compared the performance of our unit to the conventional activated sludge technology, and its superior performance compared to the activated sludge. We achieve effluent of nitrogen and phosphorus less than 1 milligrams per liter. But most importantly, we managed to reduce energy consumption by 75%, sludge production by 70%, and also a carbon footprint by 70%. So with our technology, we believe that we can support the kingdom to achieve its goal of 100% sanitation and 70% water use by 2030. We can also save the kingdom $500 million per year from electricity consumption and sludge management, and also we can help the kingdom to generate $1.2 billion of revenue from water reuse.
Impressive. So as we have some time left, the question I had for you, Pascal, is so you spin off New Rain from the university,
Correct.
from Coast. What has been the main challenges that you...
It's really funding to get...
Only fund.
If you want to scale up from 100 meter cube to 1,000 meter cube per day, which is the demonstration scale, you need capital.
Okay. And Tahir, you mentioned that you have been working with investors. Can you just explain a bit what was your journey of creating this company and finding what are the kind of investors that you have been able to attract?
Yeah, actually we started the company in March 2020. And March 2020, it was the worst time to create a company because there was the COVID right after that. But we have got this chance of having a committed investor even before the COVID, and he continued his commitment. It's Oman Technology Fund. And we managed to survive 4 years with only $200,000.
And no salary for everybody, right?
Nearly this, but we managed to get complementary funding from the state and France, etc. And we built strategic partnerships, and we just closed this year second round with led by Wellers Impact, and they are managing Water Unite Fund and Mexico's Ventures and Digital Africa. And today we have just released this AI agent, and we are opening a bridge round. We want to scale this AI agent because it's a game changer. We have so many opportunities to communicate with people, hundreds of millions of farmers, and we just created this highway to get in touch with these guys. And for this bridge, we are looking for investors that are active investors, not just money putters.
And Abbas, the question I had for you was, you work for a large corporation. 2 questions. What would you say in the capacity of a large corp to invest into innovation? And 2, what will happen to this startup with whom you are working? Are you going to acquire it, or what's the plan?
Thank you. So, 2 things. First of all, R&D is, we call it as a DNA of our company, right? So, we use a framework called earning, giving, and sustaining. So as part of our KPIs, right, whatever you earn, you have to give back to the community, give back to the environment in a sustainable manner. So R&D, we have is part and parcel of our strategy. When it comes to startups, we look at from both the angle. As I mentioned, the winner of our first challenge is a startup from KAUST, 3 students actually, and 1 very brilliant Saudi girl. We have developed a joint venture with them. We are in the patent stage to scale up the technology. For the second challenge, again, the idea is to identify the startup, scout the technology, and then co-invest. They bring in the technology, we bring in the funding part. But what I'm also looking at, and I was checking out some of the policies in Europe, is the public and private partnerships, where the actual companies like in Saudi we have Salik, we have environmental funds, where they also come into so is a government fund plus an operator plus a startup. So that triangle is probably one of the best solutions I've seen, and in this phase.
Thank you. So personally, in closing, I think because you always hear a lot of pessimistic messages around climate changes, etc. But here you see we have a real issue, which is water scarcity, wastewater treatment, and I think we can have faith in in the humanity to find technology, I would say, solutions, and also the fact that, as you said, there is a drive, public-private sector, to really finance and boost these solutions. I think it's a very optimistic message.
Yeah.
So thank you very much for listening to us. Thank you to our experts, and see you next time.
Thank you very much.
Very much.
Thank you. Thank you.